morning, students. In the previous class, we have studied stacks, correct? The definition and memory representation of stacks using two methods, arrays and linked list, that is static and dynamic representation. Then the operations on stacks and the two very popular operations, deletion and insertion, that is push, inserting an item, and pop, deleting from an item from the stack. That we have seen. Applications also we have seen. Now today in this session we see yet another data structure which is queues, right? The queues. Queue. What is a queue? The queue, the word has become so much popular, correct? You are aware of what are queues. In day-to-day life, we come across various queues, correct? If you go to, for example, a movie theater, you have to stand in front of a queue, and wherever there are services and large number of people want to get the service, the best possible way to manage a crowd, large number of people there, a big crowd, is a queue. Right? So people say that stand in a queue, because that is the best possible way to manage large number of people where they try to access the same service. The service point is same. If you go to banks, for example, there is always a crowd, right? Rush. So they say stand in a queue, or there are boards written, right? Please maintain the queue, be in a queue. So this queue has been a very most used component of day-to-day life. Now let us see what is this queue as a data structure. Queue is also a linear data structure. This works with the principle of first in, first out, right? First in, first out. Right? It is called F5, F4. First in, first out. In a stack, you have seen this works with the principle of last in, first out, LIF. But in this case, first item which is entering into the queue will be the one which has to leave the queue first, correct? If you stand first in the queue, you are the person who is served first, and after getting your service, you are going out of the queue, correct? Once you get your movie ticket at the counter, after standing for a time, then you will be getting the ticket, right? Then you will be out of the queue. So when the service is received, you will be out of that queue. So anyway, the new persons joining to the queue will be joining at the end of the queue, correct? They move forward until they get the services. Then they are removed out of the queue, right? So an item entering into the queue, right, for the first time, that should be the one to be removed first, correct? That is why it is called first in, first out. So when you draw this one in the form of an array like this, normal, right? Let us say this is a queue of items, right? Suppose the item 10 comes into the queue first, next item 25 comes, next item 15 comes, next item 63 comes, like this. So first item entered into the queue is 10, and the next item 25, next. So this is a queue like this. This is the queue, right? Like this. So new item we can join at this place, and the item at the first, at the head of the queue, right? 10 has come first into the queue, has arrived first into the queue. So it has to be removed, right? So these are not removed. The item at the front will be removed first. So total principle of operation is first in, first out. So if you have to get the services early, naturally you have to come to the queue early. That's it, right? Go and stand as early as possible in the queue, and you will be the one when the bank opens. Try to be in the queue early, right? And you may be the first one. So when the bank personnel comes there, and they will serve you first. Right? If you are joining late into the queue, definitely you will be serviced late. So that is why it is quite normal and extensively in day-to-day life, wherever you go, banks, shops, and other places, we are put into queue. So this is the best possible way to manage a crowd or large number of competing entities to get a same service. Correct? Service point is same, one or limited. So now, so by definition, a queue is a data structure. It is a linear collection of items in which addition of a new item and deletion of an existing item happen at other ends, two different ends. So the end where we add items, this is called a rear item. It is called REAR, rear item or rear item, rear end. And the end of the queue where the item is deleted from, it is called the front of the queue, front. Right? Now if I draw the same diagram, suppose this is the service counter here, right? This is the service counter, right? So there the person is sitting inside, right? So here there is a queue here. So this person stands here first in the queue, right? And back side there is one more. So this is a big queue of people standing in the queue, right? So this one, right? So there is a big queue here, right? So when the people come and join, right, they will be joined here, correct? So this is the rear end, RER. Right? This is the rear end. Right? So the new person getting entry into the queue, right, goes and stands here. He has to get the service here. So this is the service point, right? Counter, right? So this is called the front of the queue, right? Front. Right? So when you are coming to the queue, you must stand here. Correct? So the new items will be entered here. So this is suppose the new item has to be inserted at the end called the rear end. Here, from here we are not deleting items. Are we deleted from the queue here? No, it is from here. Correct? So after going to the counter, then after getting the whatever the services from that counter, we will be going out of this. So this one he gets, he is moving out of deleted, correct? Delete. So this is insert. So the end where items are inserted into the queue is called the rear end. Here, the rear end. Then it moves. The front end is the end from where we delete the items. So by definition, a queue is a data structure in which an item is inserted into the queue at the rear end, one end called the rear end, and the items will be removed, deleted from the queue from the other end, which is called front of the queue. And the principle of operation is first in, first out. So if you observe this one, first which item comes into the queue? 10. This person comes into the queue first, correct? Later this person has come. That is why he is standing backside of the first person, and behind him. Right? So the next item coming is 25. Right? The next item comes is 15. So this is the order in which they arrive into the queue. Right? So based on this principle, there are so many applications even in computers also, inside the computer. Right? There is something like process scheduling. So all those things we see in the applications of queues. Right? Process scheduling, various competing processes to be executed. Right? They are put into the queue because there are hundreds of processes happening in a working system. Right? We have so many processes, but the processor which will execute all the processes is the single process usually. Right? So in such a case, all different processes have to be executed by the help of single processor. But which process has to be executed first? For that, there should be a need of maintaining the queue. So system maintains various types of queues. Right? Some processes are waiting in the queue to be entered into the processor for execution. Some processes are into the processor. Some processes, right? Something like this. So there is a need of managing all those resources using queue system. So anyway, so queue is a data structure which can be explained like this. Examples, simple examples I have already given. Some other applications we will see at the end. Now, after this, how to represent queues in memory? Right? How to represent that we discuss. Now, already we have seen when you have a queue, the item which is entered into the queue first has to be served first. So that is the working principle. Now representation in member. So as in the case of stacks, queues can be represented using two ways. One is static representation and dynamic representation. So static representation is naturally using arrays. This is using linked list. Static representation of a queue is done using arrays, because we have seen in the discussion of stacks, an array is a static structure. So the number of items, elements which can be manipulated, processed using arrays has to be fixed at the compile time. So same is the case here. When we take an array, to consider this array as a queue, we declare it, right? So the size, the number of items which we can process in a queue becomes fixed, right, before we compile the program. So let us understand this using this diagram. So take an array of suppose 5 items. So suppose this is A of 5. So n is 5. There are 5 items at the maximum. There can be 5 items. Suppose, so this is the front end of the queue, and this is the rear end. Suppose first we enter one item into the queue, 10. Next we enter 20. So rear item is this. So when first there are no items in the queue is empty, correct? One item we have inserted. The next item, so rear is this one. Earlier front and the rear is the same, correct? When we have empty, right, front and the rear are either null, or when we take array to represent, we can take -1, correct? When we add one item, front and the rear become the same, correct? So rear is this one. Now this is the rear end. So when you insert one more, like, so this is the rear end. How to insert? Rear has to be incremented, correct? So when we have the index, to insert one more, the rear is now this one, rear end. Rear end you increment, it becomes 2 plus 1, 3. So there we enter a new item. So each time the new item to be inserted is at the rear, right? 50. Now after rear is this one. When there are 5 items, the last index is n minus 1, correct? N minus 1. Is 4. When we reach the index n minus 1, naturally the queue is full. So at this point, the status of the queue is full. Queue is full because we have taken array to represent, which is a static by nature, correct? Arrays will be static by nature. So when we take a one-dimensional array to represent a queue becomes full when we reach the maximum number of items as fixed at the time of its declaration, correct? That is why the number of items has to be fixed, and the two ends, insertion is done at the rear end, deletion of items should be done at the front end. Now let us see what is the expression to insert and delete. Now we have seen that when you insert items, earlier the front and the rear are now let us see, start from the beginning. Now the queue is said to be empty, right? For this we take front is equal to rear is equal to -1, or null we can take, null, either null or -1 we can take, as in the case of a stack. Now when we insert one item, where we are inserting? At the index 0, correct? We have to insert, and the first item will be having the index 0. So to insert item, rear is equal to rear plus 1. So this is the expression to increment the rear. Now rear is minus 1. Why do we take rear? Because items are inserted at the other end, which is called the rear end, at the back of the queue. So rear plus 1. So minus 1 plus 1 becomes 0. Insert an item. Suppose the item is 10. One item inserted. One more item has to be inserted. Where? At the next index. So rear has to be incremented. So rear is rear plus 1. Insert one more item. Let us say 20. Once again insert. Once again insert. Rear is rear plus 1. So the expression to insert an item in a queue is rear is equal to rear plus 1. Or rear is equal to rear plus 1. Increment rear. One more item. One more item. 40. One more item. 50. So now, as you know, the rear has become n minus 1 maximum. More than that we cannot insert. Now if you try to insert one more item, right, it is not possible because naturally you know it, when the queue is full, the data structure is full, we cannot insert. So now itself you can think of how to write the insertion algorithm. After this discussion we have to write the insertion and deletion algorithms in queues. So insertion, rear is to be incremented. Now what about the deletion? Delete. It is front is equal to front plus 1. Increment front. Now how is that? Let us see. Now see, when you delete this item 10, front, from where you are deleting? From the front only. So this is the front end. This is the rear end. When you delete the first item at the index 0, after that which item has to be deleted? This one, index 1, correct? So when you delete the item at the index 0, you delete first. Then at the item index 1, front incremented, front plus 1. Next you delete the item 30, which is at the index 2. That is why each time you should increment the front. Anyway, front and rear will be the indices when we represent using array, correct? Right. So increment the front to delete an item, because after time it is 20 to be deleted, 30 to be deleted. Now there is a small thing to understand. When people stand in front of a counter, as you have seen in the diagram, right? For example, at the bank, the counter remains there only, right? The people move forward, right, to fill, right? The people standing in the queue will be moving forward. The first person, after getting the service, he goes out of that. There, the second person behind him moves to that location, correct? So that is how we delete the items from there. But here, to represent that is not possible. So the way to represent using an array is like this. After deleting the first item, we move the front pointer. It is a pointer anyway. Front and rear are pointers to indicate to the positions of operation. So we have to increment the front. After 10 is being deleted, next item 20. So the service point front has to be incremented. Try to understand this. The items will not be moving here. We increment the pointer. So same is true in the case of the dynamic representation also, correct? After deleting the first node using linked list, that we see next. So front increment, front increment, front increment, right? So item can be added, but as we have taken an array to represent a queue, the number of items will be remain fixed at the time of compilation. So that is how we represent a queue using an array. So as we know, the limitation is array is static by nature. Number of items cannot be increased, right, at the time of running the program. That's the demerit. Now let us see how to use linked list to represent a queue. The operations remain same. Front and the rear are the two ends of the queue, and insertion is done by incrementing the rear and deletion is done by incrementing the front. Operations will be the same in the case of linked list representation. But to represent a queue, we take a linked list instead of an array. The advantage is we can add or delete dynamically as and when we require at the time of program execution. That is the advantage. That also we have seen in the case of stacks. Now let us say this is the first node, the second node. Let us assume that first there are two nodes. This is the starting node. Start linked list node 1. To add one, insert one node at the back side next to that. So this one. So this is the front end. So data and a link pointer to the next node. So this data and link to the next node. To insert a new node, these are nodes. Insert a new node. We have inserted one more node, node 2. Insert one more new node. So this is the rear end. So this is the front end of the queue. Insertion happens at the rear end. This side only. You cannot insert in between. So even using the array, we cannot insert anywhere in between the queue. This is against the principle of the operation of a queue. Insertion we must do only at the rear end. So deletion we must do only from the front end. In between, we are not supposed to do any operations because it is the working principle of a queue. So when you have a real queue, right, can you enter into the middle of the queue? No, the people don't allow you, correct? There are strict rules. The person will say you, he will instruct, stand behind the queue, correct? There is a queue, follow the queue principle. That means where you have to stand. You have to stand at the back of the queue only, correct? You should move through the queue. Okay. So inserting one more item will be creating one more node and attaching it to the last node like this. How to attach nodes, everything we will see later. Anyway, the new items, the new nodes are inserted at the rear end, node 3 like this. Like so. This is the last node. Anyway, this is null. So in case you require one more node, that I can do dynamically whenever the program is being run. Insert one more node here. This is the rear end. And deletion of items. So should be done here only. So this insertion. And this is the deletion. So these diagrams you can show when the question is asked, like represent queues in memory using array method, static representation, and using the linked list method, dynamic representation. So deletion has to be done at the front of the queue. So deleting the first node, then the start points to the next node. Second node becomes the start node. So this is deleted from the queue. So second node, next deletion. Next only you can delete the third node like this. So always, so this principle has to be maintained. Then this linked list represents a queue. So representation of a stack or a queue using the two methods, array representation, static, or linked list representation, dynamic. These are one and the same. The only thing is the principle of operation. In the stack it is last in first out. In the queues it is first in first out. That we have to maintain, that's all. And the diagrams for both you may have to write as it is. You have to show where is the insertion, where is the deletion. Hope you have understood this.